In today's lesson, we are talking about zeros of polynomial functions, how to find them, and what do they mean on a graph. So starting out, I'm going to give two different examples. So we're going to start with x plus 2 squared times x minus 3 times 2x plus 5. And we're going to solve this by factoring. So it's already in factored form. So we have been solving by factoring since Algebra 1. We were just factoring quadratics. Polynomials, we have just more factors. So we're going to look at our zeros from all of these. So remember, x plus 2 equals 0, and you solve it. X minus 3 equals 0. 2x plus 5 equals 0, and you just solve all of them. So this will have a 0 at -2. This will have a 0 at 3, and this will have a 0 at -5/2. But now I'm going to add in a new word. Because this was a binomial squared, this has multiplicity of 2. So this 2 is coming from the exponent 2. So now, I don't know if you have room on your notes or not, but I'm going to squeeze in a little graph about this as well. And let's talk about everything. So I'm going to just sketch a little graph, and I'm going to put these zeros on here. So 1, 2, 3, -2, and then -2.5. So solving this polynomial, we have these zeros. Those are x-intercepts on the graph. And now we're going to do a very basic sketch. We're not getting exact points, but we're going to sketch based on information we know. If we were to FOIL this whole thing out, I want to know what would just the leading term be. Multiplying, this was going to turn into x squared. You multiply here, x to the third. Oh, that's going to go to 2x to the fourth. So if you were to multiply it out, the leading term would be 2x to the fourth, and then of course we're going to have a bunch of other stuff. So take that leading term test. That is, so power 4, and it's positive here. So we know the end behavior is going to go up at the end. And now we have to think about hitting these zeros. These exponents, and I'm going to just put an exponent 1 on these, tell us whether or not we cross or touch and turn around on the x-axis. So -2.5 comes from the factor that has exponent 1. If it's an odd exponent, I'm crossing the x. But to get to this 0, I'm going to have to turn around. I don't know how far down I need to go, but I'm just going to turn around, and I'm going to come back to this 0. This 0 is -2, and because it has this multiplicity 2, if it has an even exponent, it touches and then turns around. And I don't know how far down it needs to go, but I know I need to get here. And then because of that end behavior, I know it's got to go up. But also, this 0 had the factor with an odd exponent, so I know it has to cross. So taking all that information, adding in a new word, and sketching a graph is part of this lesson. Okay, so I want to do another example, same topic. So let's do x minus 4 to the third and x plus 1 squared equals 0. So if we solve this, take one of our factors, and we have a 0 at 4, but that exponent says x equals 4 with multiplicity 3. And then this 0, x equals -1, this exponent will say multiplicity 2. And now let's think about a graph. So let's get our zeros on there, 1, 2, 3, 4, and -1. And then let's think about, if you were to FOIL all this out, expand it all, what would the leading term be? So x to the third and an x squared. The leading term would be a +1, x to the fifth, and then a bunch of things after it. So leading term, end behavior, it's positive here, odd exponent, so I know that end behavior has to be going up this way, down this way. And then it has these turning points. So let's look, okay, at -1 has multiplicity 2. So an even multiplicity, it touches the 0 and turns around. And then I don't really know what it's doing here, but I know that it has to come back up here at some point. And then an odd multiplicity, it crosses the x-axis. So I think it technically does something like this. But we're just doing a rough estimate sketch. And now one more thing I want to point out. Notice how leading term had exponent 5, and we had solution with multiplicity 3, and then a solution with multiplicity 2. 3 plus 2 is 5. And if I go back here, let's see, that leading term had degree 4, and I've got 1, 2, and then 3, 4. So for right now, we are just getting real solutions, and they're kind of, with that multiplicity, they're matching the degree of our polynomial. So we're going to be doing the same thing, except this time I'm not giving it to you in factored form. We need to factor it. So let's start with 24x to the 4th minus 54x squared. So we want to factor this, and we want to solve it. So let's do a greatest common factor. There's a GCF of 6x squared. Divide that out of both terms, and you're left with 4x squared minus 9. After you take out your GCF, can you factor what's left over? That's the difference of two squares. So this goes to 2x plus 3 and 2x minus 3. And now let's find our zeros. Here we're going to have a 0 of 0, but this exponent 2, that's 0 multiplicity 2. And then here we have negative 3 over 2 and positive 3 over 2. So again, I want to just sketch a little graph so we can start understanding these. Okay, so I've got a 0 at 0, and then a 0 at 1.5, and a 0 at negative 1.5. Leading term, let's see, degree 4, and it's positive, so I know the end behavior is going up on both sides. Okay, so this would have, these factors have odd degrees, just exponent 1. So at negative 3 over 2, it's odd, so I have to cross. And at some point I'm going to have to turn around to get to the 0. But the 0 has multiplicity 2, so I have to hit this and turn around. And then I come here, odd degree on that factor, so I'm crossing. So there's just a rough sketch of that polynomial. Okay, let's do another one. X to the 5th minus 11x to the 3rd plus 28x equals 0. This one also has a greatest common factor. This time it's of x, so let's take that out. So I have x to the 4 minus 11x squared plus 28 equals 0. Now this is a 4th degree, but it's in the quadratic form. So we will factor this down to x squared and x squared, and then minus 7 minus 4. So I've got x squared minus 7. This could go down even further to x plus 2x minus 2. And now let's solve. So here we have x equals 0. If you go to solve this one, you'll have x equals plus and minus the square root of 7. And then here we'll have x equals, well, plus and minus 2. So notice the 5th degree, how many solutions do we have? 1, 2, 3, 4, 5. And in this case, there is no multiplicity. Let's plug these zeros on the graph. So 0, negative 2, positive 2. The square root of 7 has to be somewhere in between 2 and 3. So let's just estimate here and here. Okay, so if we do a sketch, let's see, 5th degree and it's positive, so I know end behavior has to do this and this. And then all of these factors don't have multiplicity, they all have just exponent 1. So they're all going to cross. I'm going to go up, and then I have to come back down, and then I have to go up, back down. So there is just a very rough estimate of what the graph of this polynomial looks like. Okay, so now for the last examples, we are going backwards. This time I'm going to give you the zeros, and we're going to turn those zeros into a possible polynomial. So let's say that I have a 0 of 2, and it has a multiplicity of 2. And then let's say that I have a 0 of -1/3. Okay, so lots of different polynomials could have these zeros, and they could be different. So what we're going to do is just kind of take what we know and turn it into a possible polynomial. If you have a 0 of +2, that means we have a factor of x minus 2, and then multiplicity 2, which means we would have that factor squared. And then if we have a 0 of -1/3, that would be 3x plus 1. So we're going to turn this into a polynomial. So let's say f of x equals this, and now let's expand it. So this will go to x squared minus 4x plus 4, and then multiply to 3x plus 1. So I'm going to multiply the 3x to the third minus 12x squared plus 12x, multiply everything by 1 plus x squared minus 4x plus 4. Combine like terms, 3x to the third, negative 12x squared plus x squared, negative 11x squared. 12x take away 4x is 8x, and then plus 4. So taking your zeros and writing a possible polynomial that matches it. Okay, so let's do another one. Let's just say we have a 0 at 0, a 0 at 3, and a 0 at -4. So a possible polynomial, f of x equals, if you have a 0 at 0, that just means you have a single x out in front. 3x minus 3, -4 turns into x plus 4. So this one's not too bad. So we have an x. Let's expand the two binomials, x squared plus x minus 12, and then x to the third plus x squared minus 12x. Okay, so there is your full lesson on understanding zeros of polynomial functions and learning about multiplicity, how to put this information onto a graph, and what it all means together. Good luck with your lesson.